Hello, everyone. I'm Fadi Fathallah. I'm chair and professor in the Department of Bio and Ag Engineering, and I'm involved in several ag health and safety initiatives on campus, like the Western Center for Ag Health and Safety and the UC Berkeley, Davis, and UC San Francisco Center for Occupational and Environmental Health. And it's all focused on agricultural health and safety. So today what I'm going to do is just kind of give you some background. I think a lot of you are aware of those things, but just kind of set the stage for the talk. As we know, California is the wealthiest ag state in the US, and then it's ranked #1 in food agriculture production for the past probably 70 years or more. And it accounts for 50% of the fruit, nuts, and vegetables, and more than $50 billion in cash receipts, and then $100 billion in economic activity. So there's a lot of drivers for having agriculture sustainable, and labor is a big part of this, right? And we've been talking about this. So most of the 350 or more crops require labor-intensive practices. So with that, as has been discussed earlier, you need farm workers to do the agriculture work, and the range of the needed labor, how many people you need, it can range between 400 and up to 900,000. Now we're not at that level, but during harvest, during high season, you need a lot of workers to do the labor intensive, so the harvesting, the maintenance, and the packaging on the other side. And of course, as you may know, that the majority of the farm workers, they were born in Mexico, and then the majority are either from Central America or Mexico. So what are the health issues that face the farm workers? Mostly in agriculture, musculoskeletal disorders still till now the highest or the most common of all occupational injuries and illnesses. So if you compare the MSDs or musculoskeletal disorders compared to pesticide injuries, this is the one that people think that's the highest. It's not actually. The pesticide injuries is much smaller. It may get a lot of attention, but it's not really as recorded as the musculoskeletal disorders. And then all the other illnesses, so dermatological illnesses and injuries. And so it's been consistent like this, that musculoskeletal disorders or injuries to the back and wrist and shoulders, for that matter, and other knees tend to be #1 almost consistently. Several studies have been done the past 2 decades, and to come back to your question, it's still there. Like still #1, and it's still reported fairly as a prevalent situation for farm workers. So. So focusing on labor-intensive agriculture, it is still till now among the top 10 industry subsector for back pain. If you look at back pain, it's reported very highly among the farm workers. And then specifically, strain and sprain are the most disabling injuries. It's in California, it's about between 30 and 40% of the injuries, and nationally the story is still the same. You about 30%, about 1/3 of the injuries in production of fruits and vegetables. So there is a concern there, and it's still up to this date. What are the risk factors? What are the things that kind of expose those workers to potentially like back injuries or wrist injury? The big one is stoop posture. So working in a posture that forces you to kind of bend down and then stay there, either sustain or repeated stooping is a big one. And of course, you need, in some cases, you need to have products or boxes lifted. So lifting and carrying is a risk factor. And rapid hand work, so cutting, clipping, and so on, that's really another big risk factor, and the combination of all three, right? So you can have a situation where you're harvesting with a knife, so you're cutting the vegetable or the leafy vegetable, for example, and then on top of it you're stooping, and then you pack the leafy, let's say lettuce, you pack it in a box, and now and then you have to lift the box and put it on a trailer. So you're doing all three at the same time. Usually, most people will have one of these risk factors. In farm work, you're exposed to almost at least two or potentially three. That's not even considering the environmental factors, right? So you have the heat, you have when you start, and then how long you work, of course, and all compounding that. And then there's other psychosocial, cultural, legal. We don't even. I focus mostly on the physical, but those layers don't undermine those injuries. It's actually could magnify them and magnify how access to healthcare, for example, it could affect when the worker could go back to work. So those things are they play a role in that picture of the exposure to farm workers. All right, so that I just kind of to define. You've heard the term ergonomics. I thought we'll kind of define it for you. So ergon is work, and then nomos is natural law. So when you see like economics, so the home laws of the home, basically, right? So same thing in here. So ergon is work, and nomos is natural laws. So it's the natural laws of work. So how the work is done, basically, is this what ergonomics is about. And more specifically, you use the knowledge of human abilities and limitations in the design of almost anything. In our case, what type of tools we can develop, or what type of new technology that we can develop to really have the safe, efficient, and comfortable human use. That's kind of the bottom line. Are you really developing a system that is actually takes into account the human, their abilities, but more importantly, their limitations into the design of your whatever tool you're trying to do, being even an app on your iPhone, for example. Is it really designed to really have a more efficient and safe use for that application? So that's kind of set up the stage of what we're doing. So all we're doing here, trying to kind of again develop tools to kind of help the workers lead a safe and productive life. Is this thing working? I think it depends on. Yeah, but it seems like I'm cutting in and out. Can you hear me in there in the back?
This way is for the inside, and that way is for the Zoom.
Oh, this is Zoom.
Yeah.
Oh, okay. Then it's not a. Can you hear me there without the, or it's better to talk to this? Okay. All right. Sorry about that. At least the online people, hopefully they're picking me up. So if you look at interventions or what can we do about it? So if people are doing a lot of labor intensive practices, you can classify those interventions to three types. Either you reduce or eliminate the known risk factors. So you bring automation, for example, as the examples that Professor Slaughter and others are going to be sharing with you. So you basically say no more stooping, right? And because now the machine is going to be doing it for you, there is no need for it. And the others, I'll share with you an example, is some type of worker aids and protection. So some type of tools that the worker either could wear or use to kind of reduce the risk factors to get those musculoskeletal disorders, or let's say back pain or other disorders. And of course, people think that this is one way of doing it. You can do training and some administrative controls and work organization to kind of remedy this problem and reduce the risk factors as much as you could. And you can do a combination of all these three, of course. But in our experience, we found that the most successful interventions or solutions, they've been task specific, because agriculture is kind of unique. It's not like in typical industrial settings where one solution could actually work in a lot of industries. Like, let's say, self-leveling tables, for example, is a good example in a general industry where that could work almost anywhere. But in agriculture, if you're harvesting asparagus, you need a special tool to kind of go down to the root, and it's not any simple knife will do it, right? So that portability is not there as much as in the normal industry. So I'll go over this. So this is a kind of, it's dated, but still I'm trying to share with you the concept of can we do something, even a simple solution for farm work that could reduce their likelihood for getting back injuries or other musculoskeletal disorders. And that's a document by NIOSH that came out. And a lot of it is coming out from our group here at UC Davis, looking at ergonomics of farm work. And I'll share some examples from that document to kind of show you again the process. So in nursery spacing, so this is where the workers will bend down to kind of pick up the containers and try to spread it to have more foliage and more sun exposure, so they can grow. And they do that like once a week or so. So this is definitely a demanding task, because you're not only bending, you're lifting the tubs. So we came up with a simple solution. Basically, you design a tool to kind of really bend for you, right? Instead of you bending, you let the tool kind of connect to the lip of the container, and then it hugs it, and the center of gravity is lined up with your arm. So you just literally walk with it, and then you space it. So it's a simple solution that reduces the need for you to stoop, and yet it's effective in a way. So that's one example. And then, being engineers, our group kind of went a little bit trying everything in a way. So you can do multiple, like 8 or 9 ones at the same time, with the accordion type, right? Or you get to a device that does 3 of them, or 2 of them, or 3 smaller ones, and so on. So, but the same idea, right? The idea is, why should you bend down? Let the tool bend down for you. Okay. And then the document shows you the kind of before and after, right? This is before, and then it's after, and it actually walks you through what do you need to kind of develop that tool, if you have access to a shop, or you can do it in-house. So that's kind of the premise behind this. It kind of walks you through of how you can develop that tool on your own. It shouldn't cost more like $20. And there was a company actually in Canada that made them out of our suggestion, and they had them available for a while. I don't see it anymore, unfortunately. But the idea is there out there. Just quickly to show that we reduced the forward bending by at least 50%, and the grip strength. So the reason why they're using their fingers, they tip the fingers, so there's using pinch instead of power grip, right, in the tool. So there's a lot of strength in a power grip versus a pinch grip. So you reduce, if you reduce the need for the grip capacity is by at least 50%, and there's no significant change in the productivity. So that's an effective tool where the productivity didn't suffer, and then you're still protecting the workers. This is in propagation. So the workers actually need to cut these woody plants about up to 5,000 cuts a day. So they're trying to get it to the right size and put it in small containers, and then test for propagation. Eventually, it's going to become your tree when you buy it, or even in the small containers if you buy it early. And the idea is, again, you just cutting. So we had a lot of complaints from workers on this, and I'll show you kind of solution for it. It's kind of cool technology. Hopefully it works. Uh-oh. I don't think it's the video is working for some reason, but I hope you get the idea. The idea is, we took the same shear that the workers are using, and then actually have a pneumatic piston. So just all you need is air supply, and then you get a micro switch on the side, and then as you bring this is the cover for it. So this is the guts of it, and then you just activate the micro switch, and the shear will just cut it. So now the workers, all they do is just bring the woody stems, and then just literally touch the micro switch, and it's cut. We brought people back from disability because of this device, because what happened is a lot of workers were actually using their right hand for a while. After months of using, they're getting carpal tunnel syndrome, so very serious injury. They have carpal tunnel surgery on the right. So now the right is out. So what do? You're going to go to your left. You start cutting on your left. Months later, you're going to have carpal tunnel on the left. Now you have bilateral carpal tunnel syndrome. You're on disability. So we actually brought people back to work because of this machine. Now they're coming in and just literally touching the micro switch instead of using the shear thousands of times. But the nice thing about it, we actually offered to build these at cost. So we built about several hundreds of these literally at cost. Unfortunately, we're not doing it anymore, but we can entertain the prospect. So that's kind of, like I said, a success story in that. And then in sorting tasks, we've had cases where looking at the tomato harvester that's been mentioned before. And then we worked with packing houses to look at the lines and packing. So, and just take an example on the tomato harvester. Now it's done by, like Professor Slaughter was saying, so there's now vision-based quality control. But if in case you have a worker, there's a lot of vibration transmitted from the platform to the workers, and they were complaining about nausea and literally not feeling well when the vibration of the platform kind of transmitted to them. So what we did, we actually put vibration dampening material right in the apron that they were wearing, and now so you're isolating the person from the vibration as much as you can, and they definitely felt much better with the vibration foam in the apron. So, got it. All right, thanks. So that's one idea. And then in the stoop work, I've done a lot of work on stooping, and I'll share with you some basic kind of ideas towards the end. And if you're doing grafting or manual grafting or budding, you're going to have problems, of course, in your knees and the back. And then in typical harvesting, you're going to have back and to a certain extent the knees. One way we looked at this idea of a prone cart. So instead of really stooping, can you do a platform that you in a way almost sleep on, right? And now you're just picking, you don't have to stoop. This one we made basically on, it's person powered, so it's not, there's no motor, but we developed one later that is actually a battery operated motor. You just press a button. But the idea, again, you just pick as you pedal your way down. The problem is neck support usually an issue. So we have this like a massage parlor type of thing that you've seen when you sit on those massage tables. Anyway, so but the problem is there's an issue with it is with tunnel vision, right? So you just literally focusing on the fruits, and it gets a little bit probably challenging to just be focusing on that task. And but at least you'll have full support, and we did it in a way that you actually for blood supply, I mean for blood return, you need your knees to be bent actually. So it's not a good idea to have a flat bed, like an example I'll show you in a second. And then in Europe, actually, they've been using these quite a bit, trying to because their labor was expensive, and then we're reaching there almost right now. So if you're going to stoop, maybe something like this will be. These are commercially available in Europe, and they've been using them in Finland and Germany and other European countries. So the idea, again, these are all motorized. So you just, again, press a button and go. This is in Germany. So this is in pickling cucumber. So the idea is you have flatbeds on either side of the tractor, and then the workers are just picking. This is pickling cucumber, and the problem is it's just a foam, like a foam mat, and then mattress, and then you just literally pick from there, and you can see their head is below their body, so they're asking for trouble quickly. They're going to get headaches, and then the blood pressure is going to be affected actually. And the problem is what? The tractor is the one controlling the speed, right? The workers have no control over the speed. It's not an individual thing. It's a platform with 18 people. And so now you have to keep up. If the tractor goes faster, they have to keep up with the tractor. So that's one thing. And in our case, we did the same thing with, this is in Rose's, and we had a motorized one, and then we have a canopy, so it protects for the workers from the sun. And again, it's a graded platform, so you can have your knees bent, and then you work on your whatever you're trying to work on. This is for kneeling, actually, and budding and grafting. We developed this system that actually is just a padding with wheels, but there's a ratchet there that you can go in either direction. So you ratchet and it goes down or up the furrow. So instead of every time they want to go to work on another plant, stand up and then go and then kneel again, right? That's how they would do it. Now you can stay on this platform with the padding, and then just crank the ratchet, and then you just go down. So that's a simple solution for something that and then it's still stooping, of course, but at least now you're not getting up and down multiple times. Related to administrative control, we did a study back in 2006 or so, looking at hourly breaks versus only so now, as you know, people work like for 4 hours and then take a lunch break and then work another 4 hours, right? And then we said, can you take an additional 3 to 5 minutes break every hour? Okay, so you give the workers a break to kind of recover. Okay, we found significant decrease actually in reported symptoms and no decrease in productivity. So the workers actually at the end of the day felt much better because of this additional 20-minute total. And there is some physiological background why this is happening. You're actually allowing your physiological system to kind of recover. You get more oxygen actually into your system during those 5 minutes. And then you spread it over the day. So it's a good thing. So take mini breaks instead of take one big break. That's kind of the bottom line. Then we looked at what I call them weight transfer devices. Now they're called exoskeletons. Probably you've heard that term now. It's getting really popular in normal and regular industries, and it's picking up a little bit in agriculture, not as much as traditional industries like manufacturing and even service. So they have exoskeletons now for everything from overhead installation and then lifting boxes and palletizing in warehouses and so on. So they have these systems, either active systems or passive systems. So an active system basically is a motor that allows you to kind of help lift something. But we looked at those passive exoskeletons. So the idea is you get some type of like either bungee cord attached to you and then transfer the load to your legs instead of having your back working on your, allowing you to kind of stay in that posture. So these are the three that we looked at, and we focus a lot on the bender. Unfortunately, these two, they're not commercially available. This is an Australian one that I wouldn't even use because it just had a spring and attached to your feet. So there's no way you can walk and even the instruction says it takes 45 minutes to put on. Like this is, we took it to workers and they wouldn't even come close to it, as you could imagine, right? This one is just a belt. So and then there's springs on either side and then support for the chest and the thighs. So all you do, you can walk with it, and the minute you bend down, it engages the springs, so it supports your upper body and transfer it to your thighs, basically. So it has a potential. And we did some studies in the field, and then people like it. There's an issue of adjustability. There are some sizes on it, but you still, the workers really liked it because it kind of supported their upper back. And we did some basic lab work and some modeling work looking at what happens to your muscles when you do that, what happened to your legs, right? So if you do that, does it really overburden your knees or your ankles? And so we looked at that. It seems like they do provide some protection, and the trade-off is really worthwhile to kind of transfer to the legs, actually. So just to kind of quickly show you that. And there's still interest in this area. I was just a few months ago, I was contacted by a developer of one of these devices, and he's interested in doing it, and he has a nice design. It's still a passive, it's not an active one, and it's not that expensive. It seemed like maybe he's going to do it like $200 or so. So it's probably worthwhile kind of keeping an eye on that one. Remember that some people have looked at cilantro harvest, and it's a lot of stooping and a lot of cutting, right? So they cut, and then stooping. So years ago, we developed this kind of like a glorified lawnmower. Basically, it cuts it and bring it back up. And now it's like a common thing. Of course, there's the Italian version of it came out years and years ago before we adopted it in California. And now you see it now. It's very common among lettuce and other leafy vegetables. So mechanization is one way of basically get rid of the stooping, right? That's essentially what we're doing. And I'm sure Jennifer and Pauline will kind of point to some of those. The next speakers will talk about these more in details. Now in wine grape, we did a lot of work in wine grape harvest. This is manual harvesting. So these are not machine harvesting. You need to do fill up these tubs, and they can weigh up to average actually about 60 pounds. And then you run with it and then lift it overhead across the canopy. Under the canopy, you have trip hazards in there, all the trellis wiring in there. So it's very challenging type of job as you could imagine. So we did, years ago, we did a lot of work on that. So in pruning, you're going to have wrist problems, and then in harvest, you're going to have mostly you can have some wrist problems, but mostly it's going to be the back. So we did. This is called the UC Davis tub now, and we introduced a lighter tub. It's a simple solution. The material of the tub is lighter, and the volume is less. So we went from an average of 57 to 46. So we lowered it about 11 pounds, but it made a big difference on the workers and their symptoms. So we had a decrease in productivity during that short time, but it was recuperated actually after a while. So just kind of, we reduced the lifting force by about 20%, but look at the pain and symptoms. So we did it over 2 seasons. 65% the symptoms and pain get reduced because we reduced the weight. And there's no change in the aerobic capacity, and the productivity suffered a little bit. And again, like I said, it picked up. So now this tub actually now has become the standard because they realize the workers like it. We knew there's something good about it because we used to lose tubs from our trucks. So we used to have these for testing, and then literally they disappear. So luckily the workers kind of adopted. In the beginning, there was resistance because they thought they're going to be producing less, right? Because it's not macho enough. I'm not filling it to the max. They didn't realize that filling it to the max actually fatiguing them very quickly, right? Going to 60 pounds, almost 60 pounds, sometimes 70 pounds could create a lot of problems and fatigue for the workers. It's better to take a little bit multiple trips instead of overloading your tubs. And that goes for any product. If you overload it, it's not a good idea. They think they're producing more, and it's not. But being engineered, we said, can we take out all the lifting altogether? So I don't know if that video, unfortunately, is going to work. Let's see if we can try. Nope. Yeah, but the idea is basically you let the workers pick the grapes and leave the tub on the ground, okay? And this machine is built around a bobcat. We actually have a bobcat rented from Sacramento, and we built everything around it. We didn't drill a hole in it. Everything is based on existing holes in the bobcat. And the idea is you literally like scoop the tubs. It goes into like a conveyor system, basically up to the top. It tilts the the tub, and then the grapes go on a conveyor belt to the gondola on the other side. So there's zero lifting of the tubs. And this thing created, you know, I'll show you one. So this is how it's going to look like. So that you're gonna get the tubs, and then you go up, and then there's a tilting mechanism, and we actually have a vacuum at the edge of the conveyor belt, so it takes as many leaves as possible. Sorry about the video. I'm sorry. This is wine grape, yeah. This is high-end wine grapes in Napa and Sonoma. So just to kind of quickly, so what happened, we did the study with 1 month harvest, and we had 29 people working with the machine, 43 control. The machine actually they increased their productivity. We picked an average crew. At the end of the month, they were producing actually not double, but much higher than the top crew that does it manually. So imagine how much more money they could make for, and then their symptoms was reduced. And what happened is, after a month of using this, they're just cutting and then putting the grapes on the top and leaving, right? I mean, and then just keep going. So when they came back and we said, oh, there's no more machine anymore, they actually quit their job. They said, I'm not coming back to this job. I don't want to. They realized how bad the job was, right? So they actually, the whole crew quit and went to Washington to pick apples, because they said, I don't want to do this anymore. And it's it has a kind of negative effect on the grower, but the grower understood that this is just an important thing to kind of show how what we can do about this job. And then we actually, you know, shared the AutoCAD drawing with anybody that could do it. There was a company in Salinas was interested in it, and I know a lot of growers now, they're moving into mechanization anyway, so because of the labor shortage. So that hopefully that problem doesn't really stay there, but there's still some people who do manual picking. All right, and then in orchard harvesting, as you probably know, that, you know, people use orchard ladder to kind of go and pick any fruits from orchard. And so this is physically demanding. It's a high risk from a safety standpoint, because you can be unstable there. There's a high risk of falling, and the weight of the bag. So the bag is right on your side. It can weigh up to 70 pounds, and then you're going up and down that ladder, and it's really it's a challenging task. So one way, believe it or not, our department developed something very close back in 1958. All right, the idea, so it's not really new to have platforms. But the adoption is late, because people said, "Oh, it's too expensive. The machine wouldn't fit in my orchards and so on." Now it's picking up. You see much more now. People, either if they're replanting, they're considering these, and especially in Washington with apples and in North County and so on. So the idea is you basically open it up to anyone. So there's no carrying of the ladder anymore. No carrying of the bag. You just stand and then pick, and then these are adjustable. They go up and down, and now you can have anyone pick, right? You can have a 16-year-old pick. They don't have to really lift anymore, right? So the requirement of lifting is pretty much gone. So it opens up for both genders and age and strength capabilities. So that's kind of you know, good from access to labor. So you'll see more of those, I think, I believe, in orchards. And then this is one thing that we looked at on the orchard ladders. We said, well, why is 12 inches? Why 1 foot the separation or the rung spacing in the ladder? Nobody knows. Okay, it started in 1927 we couldn't find out why. I think they just said, oh, 1 foot sounds good, and this is the standard. Even OSHA says 12 inches. And then we asked, like, why? Literally, no one knows. So we said, well, could there be maybe a problem with if the rung spacing is really too high for people who are maybe shorter? So they have to use more of their range of motion, or how much really bending of their knees they're gonna do up and down, and they may get fatigued much faster. And we did a study actually in the lab and actually with workers. So we introduced these 11 and a half, 11, 10 and a half, and 10 inches, and a 12-inch. And we had like 40 workers using it. And so all the people pick those kind of non-traditional ones or custom made. Out of the 39 people that we tested, only one person went back to 12 inches. Everybody picked either the 11 or 10 and a half. So that shows you that, you know, they don't want to go back because they realize, you know, it's much harder. I was skeptical, honestly. Like, where is 1 inch going to make a difference? If you try it, you'll get convinced. I mean, it does make a difference. If you're doing it once, you're just going to pick a light bulb or whatever. That's not a big deal. But if your job is to go up and down, the cumulative fatigue is there. It's gonna really create a problem for you. And we did kind of like confirmation study with the lab. We have motion analysis system to kind of look at what type of motion your system will use to kind of complement the field study. Right now we're looking at harvest aids. You've seen those, and it was brought up in the morning about what happens to the workers, of course, and that's what we're looking at. Like what happens in a traditional picking, you're gonna walk all the way down to the end of the row and to deliver the crate. Now you basically you're so close, you're gonna just literally like walk a few feet and then you're depositing. So you're continuously picking, right? So we're trying now to simulate those kind of scenarios of how far is the harvest aid away from the workers, and does it give them enough to recover? And are you driving them too harsh, basically, right? I mean, are they picking nonstop and then becoming a problem for them? And then Professor Vijaykas will follow up. It was mentioned in the morning with Professor Slaughter, talk about collaborative robots, and we're collaborating with them, with Professor Vijaykas, to look at what is the effect on the people if you have a robot that picks for you. Can we use it to deliver water, for example, or really back off from really having the workers pick, right? So give them a forced break, like we discussed before. So that's going to be discussed tomorrow. What else? And then we looked at, so this now is going to become into like a basic understanding of why stoop posture are bad for you, okay? So we actually did a field study, kind of like controlled field study with some electromyography, so the muscle activity of your back and some posture, looking at your posture and your muscles, basically, while you're doing tomato harvesting. And just in a nutshell, to show you what happened, this is the angle of your trunk as you're working. So this is 5-minute increments. And as you're stooping, you actually have more range of motion. So your back kind of goes down even farther. Okay, that means you maybe actually your spine becomes unstable. So you have laxity in your ligaments and your spine. And then if you take a break after this kind of 1 hour of work, you may recover from it. So the idea is it's kind of in line with the 5-minute break that we talked about. Now it's on the mechanical side of what happens to the spine. So this is kind of more backing that you should take a break actually every hour. That's basically the message in here. And then we did some basic studies using basically pick spine. We take those spines and load them as if simulate stoop work. Okay, so this is stooping versus no stooping. Think about it that way, and look at what happened to the hydration. Hydration to the disc is very critical for its health. So this is on your spine disc, and just to kind of quickly show you what happened is this is the height, how much the disc will lose height in various regions of the posterior or anterior of the disc itself. And this is total weight loss. So if you're stooping, you're losing about 35% of the weight of the disc, versus if you're just standing up, you lose only 25%, and versus there's no load whatsoever, about 10% with time. So this is just to show you the areas of the disc where the loss is there, and always the stoop is gonna have less water content in it. And again, the water content in the disc is critical for its health. So that's yeah. So you get less water. This is the water content is like 55% versus 70% if there's no loading whatsoever. Versus if you're standing for 2 hours, it's about 60%, but you lose even more if you're stooping. And this is a take-home message in here. So this is showing that if you back off now from loading, how much time the disc will take to recover its water content. So this is time versus stoop versus standing upright, and then there's no load whatsoever. The idea is you need to rest, you need to sleep basically for your disc to actually get back its content. At night, your disc will actually imbibe fluids, imbibe water basically, and then it transport metabolites and all that. So it's important to really have that rest for the disc if you want to reach this level in between these two. And stooping, you take you about like literally 24 hours to really recover fully, versus about 14 hours in if you're standing, for several hours, versus there's no load whatsoever, like sleeping. So this is basically the take-home message is take multiple breaks along the way and then sleep at night, right? This is the kind of simple message in there. So this conclusion, I hope you share my kind of ideas that ag workers, they suffer excessive high incidence of musculoskeletal disorder due to the labor-intensive work that they do. And there's multiple risk factors. They're not just exposed to like upper extremity, somebody who's like aligning something like all day. They're doing that, and plus other factors. So any interventions or engineering changes to task or tools have been shown to be effective, when they're task specific, when you're actually looking at the task and then try to kind of come up with a solution, which kind of makes sense on that. All right, so that's all I have. Just kind of, there are a lot of people involved in this group. It's in the past 25 years or so, and funding from NIOSH and USDA and the UCNR. I guess I can take a couple of quick questions or.
Okay, thanks. Tree fruit harvest, there's 3 flavors. There's a bag, and then there's a rectangular tote that's suspended to the neck strap.
Yep.
And then a pick bucket that's usually hung on a hook on the ladder.
Yep.
Have you looked at those 3, and are there any differences?
Yeah, our group has looked at them, and we actually developed a better strapping for the side ones that distribute the load better than the traditional one, the small strap. We didn't look at there's another colleague in New York that looked at the bucket one, the front bucket one, and looked at ways of actually connecting it better to the hips to reduce the loading on it. So there's still some work on that area, but we haven't done it like in an extensive way. But we developed our own bags that we think it's a better system than the existing one. Does that answer your question? All right, thank you. All right, so I'll be back. So if you have some questions, and we can have it during the Q&A panel. Thank you again, and look forward to seeing you. Yeah,
I just have a question for a participant online with you. I think you could address pretty quickly. It's like, what is the weight for those pot? The maximum weight that you can carry for the pot?
It's 5 gallons.
5 gallons.
Yeah, 5.
Okay,
Yeah.
thank you.
Yeah. Sorry, I have to go teach, and I'll be back. Thank you so much.